Okay, I came across this quote the other day, and I think this might be something I might have to get a poster of and hang up in my room, just because I kind of live by that philosophy, I think. Today, we're going to talk about the law of cosines. So you should have already gotten an idea of the law of sines, and it's a pretty easy one, law of sines. The law of cosines isn't too bad either. It just takes a little bit more work than law of cosines. So once again, we're going to have triangle ABC, and the sides across from them are going to be across from big A, little b is across from big B, and little c across from big C. So law of cosines simply says this: suppose you have little a squared. That is equal to b squared plus c squared. You're saying, hey, that looks like Pythagorean theorem. Well, it's a lot like Pythagorean theorem, except for we're not dealing with a right triangle here. Or it could be, we don't know. And we're not done writing out the equation either. So we're going to say minus 2bc times the cosine of A. I'm starting to run out of room right here. Let's draw a line kind of separating it. So that's one set there. You could say b squared, and really these next two equations I'm writing are exactly like this first one, but we're kind of isolating the a squared and b squared and then c squared here. B squared is equal to, see, notice up top we had a squared equal to the other two sides squared and added up. We're going to do the same thing here. A squared plus c squared minus 2 times, now notice up here again we said minus 2 times the other two sides, not the a over here that's by himself, 2 times bc. Well, here we're going to say b's by himself, so we're going to say 2 times ac times the cosine of, and notice we use the angle across from little a, so here we're going to use the angle across from little b, which is big B. Pause the video, see if you can figure out the equation for c squared. I want you to notice the pattern here to help you memorize this thing. I should have paused it and should have found that c squared is equal to the other two here, which is a squared plus b squared, minus 2 times the other two, which is ab, times the cosine of the angle across from little c, which is big C. So at first glance it looks very confusing. After you get down one line, the other lines you could you can write those out pretty fast once you memorize the first one there. So let's look at some problems with law of cosines. So suppose we have another triangle here, so draw yourself a triangle. And I'm going to call this angle up top 120. Here we can label it too if you want for this first one. A, C, and B. This is little a. This is 9. And this is 5. Notice there's not enough information here. Well, actually, it's not so much not enough information. We just can't use trigonometry or the Pythagorean theorem because it's not a right triangle. There's not enough information to use law of sines. For law of sines, I would need to know one of these two angles, B or C. So this is a case where I'm going to use law of cosines. So for the law of cosines, we know that this little side a squared here equals b squared plus c squared minus 2bc times the cosine of big A. Now substitute what you know in. You know little b, it's 9. You know little c, it's 5, minus 2 times 9 times 5 times the cosine of 120. That all equals a squared. So take a moment and punch that into your calculator. It should get a squared is equal to 151. Square root both sides, and you get a equals about 12.3. So that's little a, 12.3. Now, I want to solve for b and c as well. Well, I'm just going to actually start with solving for b. Now, I know enough information now to use the law of sines. So we prefer to use law of sines when we can. Why? Because it's so much easier than punching all of this mess right here into your calculator. you can make a lot of mistakes. By the way, make sure that right here you subtract. What you're subtracting is not 2 times 9 times 5, but it's 2 times 9 times 5 times the cosine of 120. So you got to multiply all this stuff together and then subtract it from this mess right here. So these guys just do your order of operations, you'll be all right. So to figure out angle B, I'm going to say, well, that's the same thing as the sine of B over 9 is equal to the sine of 120 over 12.3. So that's the law of sines. If you don't remember the law of sines, go back, watch my other video on law of sines. Here we're going to cross multiply. We get 9 sine 120 is equal to 12.3 sine of B. So I'm just going to go ahead and punch in 9 times the sine of 20, not 20, 120. That equals 7.79. Divide both sides by 12.3, 7.79 divided by 12.3 gives me 0.63 repeating. Now how do we solve for B? Go back to when we did right triangle. If we wanted to get rid of this sine and just get B by itself, we're going to have to take the sine inverse of both sides. I'm going to move this up top right here. 0.6 and with the 3 repeating equals sine B. Sine inverse of both sides, so you take the sine inverse of 0.63 equals B. And so I get 39.3 is equal to B. And that's in degrees. So 39.3. Now, how do we solve for C? Well, you could use law of sines again here if you wanted to. But can you think of an easier way? Well, we know that this one's 120. This one's 39.3. And we can all go all the way back to the beginning of the year on geometry and say, hey, I know all 3 angles must add up to 180. So 180 minus 120 gives me 60. And then 60 minus 39.3 gives me 20.7. So C must be about 20.7 degrees. Okay? There's your law of cosines. Try out some examples. If you have any questions, let me know. And have fun.